Hi everyone, welcome back to another AP Chemistry tutorial. In this video we will be discussing how to read the periodic table, how to calculate average atomic mass, and talking about how isotopes work. First of all, let's discuss the three main categories of elements on the periodic table: metals, nonmetals, and metalloids. Metals, as you can see, this part comprises the majority of the periodic table. Metals are known for being malleable, extremely conductive of electricity, and shiny, or in scientific terms, having luster. Metals also exclusively have ions with positive charges, otherwise known as cations. Nonmetals. These are the elements all around us, mainly because many of them are gases such as nitrogen and oxygen. These elements, when they form ions, typically form anions, or negatively charged ions. Nonmetals are pretty much the opposite of metals. They are not conductive, very brittle, in other words not at all malleable, and they are very dull. Metalloids. This is where it gets tricky. At this part of the periodic table, we have this little metalloid staircase. Metalloids are in between metals and nonmetals. Being the border between the two groups, they share properties of both, but that's really all you need to know about them because they don't come up much. Now, let's talk about the subgroups. In the metals, there are three main subgroups that you need to know. The alkali metals. When you think metal, you probably don't think soft. Alkali metals are special because they are soft enough to be cut by a knife. However, they are also extremely reactive, forming a protective coating as soon as they are exposed to air and reacting vigorously and violently with water. The most important thing you need to know about this group is that they always form a +1 charge when they become an ion. No exceptions. Alkaline earth metals. These are like the alkali metals, just a little less extreme. The major difference is that you must know that these metals form a +2 charge. Once again, no exceptions. Transition metals. This subgroup is split into two small parts, but they are functionally the same. These metals are the metals you see all around us: iron, cobalt, lead, gold, nickel. The reason these metals are so common is 1, because there are so many of them, and 2, they are actually the most flexible of the metals. They can form multiple charges, even some of them up to +7. In the actual periodic table you have the transition metals, but down below you have the inner transition metals. Once again, they are functionally the same, they just have different names. When we discuss electron configuration, that's when we'll talk about why they're all the way down there. In the nonmetals, we have three major subgroups that you need to know. First of all, the noble gases. If you've ever taken any sort of chemistry, you probably know about the noble gases. These gases do not react, they are colorless, odorless, but they can change your voice. Next, we have the halogens. These gases are pretty much the opposite of the noble gases, and some of them are even liquid or solid. They react vigorously with most metals, and just like alkali metals form a +1 charge, these elements always form a -1 charge. Finally, we have the chalogens. The chalogens is 1 over from the halogens, and the important thing to know about them is they usually form a -2 charge, but not always. Now, let's discuss the second major topic, average atomic mass and isotopes. Remember how in the last video I told you about hydrogen, which only has 1 proton but can have up to 2 neutrons? I basically gave you a preview of isotopes. Isotopes are elements which have the same number of protons and are therefore the same element, but have different numbers of neutrons. Remember that while neutrons have no charge, they do add mass. For an example of different isotopes, let's look again at an example of hydrogen. For the sake of simplicity, science has given protons and neutrons each a mass of 1 atomic mass unit. While electrons are so small, they don't weigh a significant amount. Now, hold on a second. Why don't we use grams, the official SI unit? Atoms are so small that we had to make up our own unit, and this is kind of the unit you see on the periodic table. More on that later. Anyways, hydrogen. If hydrogen just has 1 proton and 1 electron to balance the charge, it has a mass of 1. If hydrogen has 1 proton and 1 neutron, it has a mass of 2. And if hydrogen has 1 proton and 2 neutrons, it has a mass of 3. Makes sense, right? Now, let's travel over to our friend, the periodic table. First of all, we have the atomic symbol. Easy enough. At the top, we have the atomic number. This tells us how many protons we have in the atom, and if the atom's neutral, it also tells us how many electrons there are, because they're the same. Remember that if the top number changes, the element is different. In the middle, we have the atomic mass. Now, if we look at the square for hydrogen, you might be confused. Why is it 1.008? We discussed hydrogen with masses 1, 2, and 3. While atomic mass itself must be a whole number, this is not just atomic mass. No, this brings us into our next topic. What you see here is average atomic mass. For a better example, let's look at carbon. When you usually take an average, you just add the values up and divide by the number of values, but that's not how it works here. When we look at elements such as these two naturally occurring isotopes of carbon, we see that they appear at nature in different rates, and the average atomic mass must reflect that by being a weighted average. To calculate that, we take these percentages, convert them to decimals, multiply them by their respective weights, and add them to get 12.01, or carbon's average atomic mass as seen on the periodic table. Let's do one more practice problem. In this example, we have chlorine. We're going to take the 75.78% and the 24.22% and convert them into decimals. Then, we are going to multiply them by their respective atomic masses and add them to get 35.45, which is exactly what you see on the periodic table. Well, that's all I have for you guys today. I hope this video helped you understand the periodic table, isotopes, and average atomic masses. Next week, we'll be discussing how to put elements together to get compounds, one of the foundations of chemistry itself. Thanks for watching, and I'll see y'all in the next one.